Okay, let us talk about the GSM frequency band today. As you know that we have a different kind of band in GSM. We have this GSM 900 band megahertz, where you have some frequency which is in you know that the GSM is a duplex system, so we have certain frequency in downlink, we have certain frequency in uplink, so it is a pair of frequencies. So we have uplink frequency in the normal band start from each 90 megahertz to 915 megahertz, and we have a downlink frequency which start from 935 megahertz to 960 megahertz. And you can see the distance between these two, which is we call it as a duplex distance, call as a duplex system, sorry, the duplex distance, which is 45 megahertz. We keep this the distance to avoid the interference between the uplink and downlink. Okay, so you can see here we have a total band available. If I see how much total band is available in uplink in 900 megahertz is 25 megahertz, and in the downlink also we have 25 megahertz. So they are the pair of frequency, and for each frequency, okay, so this all frequency means we have 25 megahertz. What we do for the 25 megahertz, we divide them into 200 kilohertz. So one frequency, when we say one frequency in GSM, is equal to 200 kilohertz, not megahertz, my mistake. Yeah, so if you divide this, if you divide 25 megahertz divided by 200 kilohertz, you will get 125 frequency. Okay, so you know that this is what it is. It start from here, and this is where we stand, or we stop here. So start from, let's say it's 90 megahertz in uplink, talking about the uplink, and 915 megahertz where we stop. And the second frequency is like, it is from let's say for example it 90.2, as one frequency is 200 kilohertz. So this is our carrier frequency or center frequency. So now from here, this is our carrier frequency. We take 100 here this side, we take 100 here this side. So you can see this is what our one frequency, and you can see here this space is my limitation here. This space is 100 kilohertz, which we don't use because maybe somewhere here is some technology are using the frequency, so we cannot use that. So we need to keep some 100 kilohertz as a kind of guard frequency between the different band. And in India, if you see here, 890 below, we use this frequency for the CDMA. So CDMA operator, they use this. So you can see this is my first frequency, right? So you can I can tell you this is my first carrier frequency. Now my next is 890.4, like this. You go up to here, and you will find out in the last also you have to keep 100 kilohertz, because anyway this is, you have to keep a spare for guard band, you can say guard band. So you can see usable frequency, I mean total I calculated is 125, but we cannot use those all 125. So 125. So what we can say is usable frequency in 900, usable frequency and 900 is 124 frequency. So this is what in uplink, similar in the downlink. And so downlink, let us draw the downlink here to compare both the frequency band. So this is our uplink. Let us draw the downlink here. Let me change the color here. Okay, so the same downlink is also almost like 25 megahertz. As we know, it is a pair of frequency, and it start from 935 and it's end from 960 megahertz. Right now, again, you can see, I mean, the first carrier frequency is 935.2, where again you have 100 here this side, you have 100 here this side. So this is what I call it as a one frequency. And here again you have to take the guard band also. So this is what my guard band, and this is what I don't use. I mean, this one, this is 100. I need to sacrifice 100 kilohertz. So same way here also I need to sacrifice 100. So this is again 100 kilohertz I sacrifice. So you can see here, so this way, I mean, this is your first carrier, maybe second is here, which is 935.4. likewise you can see this is all your frequency. Right now, when I'm saying I'm on frequency, let's say number f1, let us give a frequency name, because it is very difficult to understand or remember the carrier frequency. So you can understand, if the first frequency in uplink is 890.2 megahertz and here is 935.2 megahertz, so it is not easy to remember. So what we do is, we have given this the number to those carrier frequency. So let's say the first frequency for the uplink is 890.2, and for the downlink of the pair of this frequency is 935.2, and this is, we call it as a frequency number 1, or you can say only 1 is enough. And this is, we call it as a ARFCN. What is ARFCN? As we know that to remember this frequency so easily, I mean, it's very easy to remember that frequency number 1 rather than understanding this megahertz and remembering those number. So ARFCN means absolute radio frequency channel number. So you have this frequency, means now you know that we have a total frequency in 900 is 124. So that you can give a number from the frequency from 1 up to 124. Right, so you can see the total usable frequencies in the 900 is 124. Now if I look at, I mean, like in one of the operator, let's say in India, means everybody don't get, I mean, all the frequency, because this is a very limited spectrum. And initially in the India we got 3 operator in 900, and everybody got certain frequency. So you know that the total the band is available, which is around 25 megahertz. Right, so total band is, or total frequency is 124 numbers. This is the total frequency. If we divide between the 3 operator, so we'll get approximately what, 41 frequency per operator. And if I am one of the operator, I have a 41 frequency available with me. Now in this 41 frequency, I need to manage my network. Right, so what I do is, I mean, in the 41 frequency, so we have 41 frequency. Now in GSM you have one frequency, means, so what we did so far is we divided our 25 megahertz, we divided into small frequency, and each bandwidth of the frequency is 200, and that way we got 124 usable frequency. So what we did already is FDMA. So we have divided our band into different frequency. Now for those each frequency, again we divide in a 8 time slot. So one frequency is equal to 8 time slots. So how to explain this? Let me tell you one example of the real life. If you have one chair, let's say you have one chair and you allow to sit around 8 people, how that is possible, how it is possible. So how it is possible means the we have a one chair and we can allow to sit the 8 people in the one chair. I can do it. I mean, if I tell them, I mean, this is a one chair and there is a 8 people are there, right? So this is 6, 7 and 8, and I tell each people to only stay or only sit this on this only occupied this chair only for 577 microsecond, and after that they have to stand up and they have to release this chair for somebody else. So just like here the first user come, right, and then he stay there for 577 microsecond, and after that he has to vacant. So I can say the first user, then I will say okay, now the next user will come, is the second user, third user, yeah, the fourth user, fifth user, 6, 7 and 8. You can see each people are just sitting there. So this is how we are setting the chair. I told the first person to sit just for 577 microsecond, 577, same way other has to do that, and after that again I will tell the first person to come and sit over the chair. So you can see that I mean the total time what we are taking here to ask the same person to sit over here is a 577 multiply with the 8, so that is is 4.615 millisecond, right? So this is how we are managing the 8 people or 8 user over the one frequency. So one frequency you can compare with one chair, and there's 8 people you can accommodate in one chair. So let me tell you what more easy way. So there's one frequency means I can tell you that this is what our one frequency, and the one frequency you have a 8 time slot. Sorry for a bad drawing because it's not easy to use the tablet one. Yeah, anyway, so now you can see we have a one frequency, 8 times